Hi, this is a video for compiler design, COMP442 and 6421. This is for week 8. In this video, I'm going to present assignment number 4. The topic of this assignment is semantic analysis. Essentially, what you have to do in this assignment, well, starting from the abstract syntax tree that you built in assignment number 3, you will be doing, well, first of all, building the symbol tables for the program that you are compiling. And then from the information that you have stored in the symbol tables, then you'll be able to do the semantic analysis to eventually figure out, to do the bindings between the variables and functions that are being used in the functions and their definitions, which is going to allow you to then check if they are properly used according to their declaration. Eventually, that will lead you to do some kind of type checking and so on and so forth. So there's a lot of things that are involved here, but it's not necessarily that they're all complicated, but there's a lot of things. That's a lot of different checks to be done. For the building of the symbol tables, this is kind of a, all or nothing. So you have the symbol tables or you don't. But for the semantic analysis, this is where, in the project toward the end, it's very, in different courses, it's possible. With your other courses, it's possible that you'll have projects due at the end. That's why it gets hairy at the end of the semester. I understand that. So that's why I'm going to give you the list of exact things that need to be done. And then if you're eventually running out of time, then you can pick and choose different things, and you show me that you can do the semantic checking for some things, but you maybe don't do for other things. Same thing will go also for assignment number 5, the last one, for code generation. Very often some students run out of time at the end, but still you can be doing the code generation for some of the things while not doing it for some other things. It's going to lead for your generated code to, if you don't do everything, it's going to lead the code to possibly be invalid, but at least you can show that you can generate code for some things, not for others, which I'm going to give you the grades for what you did, even though possibly your generated code doesn't work. All this to say that from now on, after building the symbol tables, you will going to have a list of things, for example, semantic checks to be done. It's going to be quite a long list. Then you start with the things that are more fundamental, and then you, if you have some more time, then you hopefully do everything on the list. But it's possible that you submit your assignment. There are some semantic checks that you don't do. It still can continue to assignment number 5. Okay. Okay, so let's go to, okay, so this is where you find assignment number 4, handout here. Then once you get to this handout, then you get into this folder here, and you find this assignment number 4 here, which I'm going to present in this video. Well, there is, especially for the presentation of what are the, what is the, all the various kinds of semantic analyses that you have to do for this assignment. I'm not going to present this extensively in this video. However, it's important that you come to class so that we will discuss these things. Okay. Because there's a lot of things, various things to discuss. I don't want to repeat that over and over again here and in class and so on and so forth. So here I'm going to fly over what is it that in general is I'm asking you, and then please go in class and see, have some discussion about it. What I did here is give you, well, the main thing here that you have to do is in terms of outputs that you have to generate, as the previous phases, you had to generate files to demonstrate what you're doing. Here, there are 2 things. One is the symbol tables. So you're going to be constructing symbol tables for essentially for each scope. So you're going to have a global, start my sentence. So you're going to have a global symbol table that essentially contains the one entry for every identifier that is defined in your global scope. So that would be your class names and your function for your free function names. Okay. So one entry in the global table for each of the classes that are declared in your program in the global scope, and one entry for each of your free functions, including eventually the main function. So that's here some example files that I gave you. For example, for this bubble sort, same program that we had from the start. Bubble sort program here corresponds the symbol tables, which you can output in a text format, for example, like this. So this would be here your global symbol table. And then you have the function named bubble sort. Here you have the specification of this function. It takes two parameters, one array of integer and then an integer, and then returns void. And then you have the inner table for the function bubble sort. Then in this bubble sort function, you have a bunch of variables that are being declared. And here you have their name and what is their type. So that allows you, after you have the symbol table generated, when you go inside of the scope of this function and you traverse the tree, where you use parts of the tree where you, for example, have statements that are using these variable names or using some IDs, then you can check if these IDs are declared or valid inside of the scope by looking up inside of your symbol table for the scope, for example, of the bubble sort function that you're currently traversing in the tree. Eventually, also, you're going to have to do some type checking. When you have an entire expression, you have to check what is the type of, for example, this is an assignment statement. You have to, if you assign a certain value to a certain variable, you have to check if the value that you want to put into this variable is of a compatible type with the type of the variable you want to assign to. Hence, you have to figure out what is the type of the expression that is to the right of the assignment operator. Then you check if it is the same type, if the type of the whole expression on the right is the same type as the variable that is stated on the left of the assignment operator. For example, so that's what it allows you to do, to have this table here, allows you to do some bindings of your variables. For example, when you use variable n, then you know this is this variable n here as declared. That's its type. And then when it's present in a you can in an expression, then you can check if it is first properly declared. If it is, then you can have some kind of binding here and to realize that this variable is an integer. For example, if you're calling a function inside of another function, then you can check in the scope of this function if this other function is available. And then you check into the table, the entry that corresponds to this function, and then you can check if when you call this function, if it is being called, first of all, if this function is properly declared in the scope. Second, if it, when you call it, if it's called, for example, with the right number of parameters and the right type of parameters. And then the return type tells you what is the value, the type of value that is returned by this function call. Then you can determine what's the type of the entire expression in which this function call is participating. So this is an example of your, here you have for a function bubble sort, it's stable, the function print array, it's stable, and the function main, and it's stable. Okay. So that's the first step of this assignment, is to construct the tables. There is, being said, very important aspect of this assignment. If you look here, actually not there. So let's go here. Here, visitor for all phases. So one extremely important aspect of this assignment is when you traverse the tree, what you have to do in this assignment is traverse the AST, and then when you come upon different types of nodes, then you have to trigger some semantic actions. So for example, if you come up onto a node which is a variable declaration, eventually what you're going to do is to create an entry in the symbol table in which this variable declaration is appearing. Or if you come up with a subtree about a parameter declaration, then again, you're going to create a variable declaration in the scope of the function in which this parameter is being declared. If you come across a node that represents a data member declaration, then this will lead you to create an entry in the local table for this class to which this data member belongs. Okay. All this to say, you're traversing the tree, and then depending on what kind of node you come upon, you're going to create a semantic action that's going to be triggered when you actually come across a node of this type. So as you traverse the tree, depending on what type of node you come across, you're going to trigger a certain semantic action. Okay. So the typical way nowadays, or one of the typical ways this is done, is using what is called a visitor pattern. I'm not going to explain that here. If you look in the video for the here, tree traversal and symbol table generation, this is actually describing, the slide set here is describing how to use the visitor pattern. It is very well explained, very well explained also in the video, very extensively described. That's the word I was looking for. So please listen to the lecture and look at the slides to figure out how to do the visitor pattern. It is not self-evident how to do it. You might think is a challenge when you look at the visitor pattern. You might say, well, I have my own way to do it. I think it's going to be more simple. Reality is that the visitor pattern has, it has this steep learning curve in the beginning, but once you get the hang of it, it's going to make all the rest of your entire project so much easier. Okay, so I can't stress that enough. Very important that you, as much as possible, try to use the visitor pattern. I say as much as possible because, I'm giving you freedom to use whatever language you may want to use. Now, if you don't use an object-oriented programming language, you won't be able to use the visitor pattern because it's an object-oriented design pattern. Yeah, okay. So, here, the video here and the slides are describing that. And then here is some example code that I designed myself as a Java program, which basically is creating an AST and then implementing the visitor pattern that builds a symbol table, as well as does some semantic checking by traversing the tree. Another beauty of the very convenient aspect of the visitor pattern is that for each phase, for each traversal of the tree that you may want to do, basically a compilation phase, you can implement a different visitor. Once you have the tree traversal done, the traversal part done with the visitor, which is one part, then it can actually enable you to design each of the consecutive phases of the compiler, for example, symbol table generation, type checking, and so on and so forth. And then eventually for code generation, you're just going to design a new visitor that is going to do these other phases. Okay? But once you started with the first one, each of the new phases is going to be very easy. Well, figuratively speaking. Or comparatively speaking, if you want to do this manually, you may think, I have my own idea of how I could do that. It's possible, but the visitor pattern is making your life so much easier. Again, when you look at it the first time, you're going to think, oh my God, this is confusing. But once you understand it and you start coding it, it's going to become extremely easy comparatively to actually design each of the traversals that you actually need for each of the consecutive phases of the remaining of the project. So very important, please look at the visitor. We will discuss that in class. It's going to be discussed in the lab. You have the video there. So you have lots of resources here to figure out how it works. Visitor pattern is one of the, I believe, one of the most interesting and useful design patterns out there. Okay, so then let's go back to this here. So that's my symbol tables. Of course, also the next thing we want to do after you have the symbol tables, then what you're going to be able to do is to do another traversal of the tree. Once you have the symbol tables for each of the scopes, then you're going to be able to retraverse the tree and then concentrate on the use of these variables that are and IDs essentially that are have been entered in the table. For example, when you declare a variable of a certain type, which is of a class type, then you're going to be able to look up in the symbol table to see if this class that you're trying to use now has been declared and if it's available in the current scope. If you use a certain variable inside of a function, then you're going to be able to check if it is accessible or defined in this scope. Eventually, also, you will be able to do type checking, as I hinted at before. So you could do that in different phases. Okay. So once you have the tables, it enables you to do a lot of different kinds of checks, and including, for example, type checking, and when you call a function, whether it's called with the right number of parameters and type of parameters, and so on. So build the tables, symbol tables, first step. Then you can do all kinds of checks, which can be done all individually in a subsequent phase. Eventually, also, you're going to find some errors. Let's say you use a certain variable, and then in this scope, it's not declared. So you're going to output an error message, for example, like in the semantic errors file here. Yes. So you're going to output if you compile this one here. Okay. This, see this. So what I did here is I essentially listed all, or most, I might say, of the semantic errors that you may be able to find. Okay. So there's a lot of different things that you should check. Not, as I said before, it's possible that you'll be able to do some of those, and then possible that you don't have enough time to do the others. So that's the beauty of this assignment. You can do what you have time for. If you don't have time, it does not make your compiler unusable for the next phase. Okay? It just is not going to be able to locate some kind of semantic errors. Could still be able to generate code even if it does not find report correctly all the different kinds of semantic errors. These are all different aspects of semantic checking. And then I've given a number to them here. That this number, by the way, refers to the numbers that there is in the assignment statement, as we will see later. And then here in the program, I've introduced some errors. For example, here, you're declaring a variable of type small a. If you look here, there's no such thing as a class that has this name. So essentially here, what it should do is to say that this type is an undeclared type. Okay, so if you see 11.5, undeclared class. Okay, there's plenty of these kinds of errors, and each of them has to be located in a specific way by looking up in the table and so on. So depending on what you're checking for, you're going to have to check different things in the table. So just an example, I'll let you go over this and then figure out the list of things that you have to check for. Again, repeat, it's possible that don't think that if you don't do everything that you will not be able to proceed further in assignment number 5. For the semantic checking, you actually don't have to do any kind of semantic checking in order to enable you to do code generation. Okay. So you could do a partial implementation of semantic checking. That would still be okay to continue to the next phase. However, you want to maximize the grades you will get, of course. Okay, so this is for that. Okay, let's go to the handout. Okay, so for this you have 2 weeks, so it's not a lot of time, as you saw for assignment number 3. Oops, it should be number 4 here. Assignment 4. So for assignment number 3, generation of the AST, you saw that it's not a lot of time. Given 2 weeks. Same thing is for the 2 others. You have 2 weeks to do that. Okay, so first thing first, well, you have generated the AST. Now you have to somehow traverse this tree and then do 2 things, which is first do the generation of the symbol tables. And then second, once you have this, it will enable you to do some semantic checking and type checking. So what you do is that you traverse the tree, and then as you come up nodes of a certain kind, then it will trigger a certain semantic action. Okay. That's either in the first phase, the semantic actions are going to, you come across, let's say, a class declaration node, then what you're going to do is to create a local table for this class. Then eventually, when you go inside of the class, in one of the children of the class declaration, then you're going to encounter a data member declaration. Then when you come across this kind of node, then you're going to create an entry in the table for the class, and so on and so forth. So basically here you are processing things which are being declared, which is going to make you create either a subtable or an entry in the table in which this thing that is being declared belongs to. So that's it for the semantic actions for the generation of the symbol table. And then once you have this, then of course you're going to output the tables to a file. But these symbol table data structure essentially are going to be linked inside of your table. Inside of your AST. For example, for the node for a certain class, in this node, there's going to be somehow a pointer or a reference to the table for this class, the local symbol table for this class. So that as you are processing, as you are doing the second phase, then as you are processing, you're traversing the tree again, let's say you come to a certain statement that is using a variable X, then you'll be able to, from the table that is stored in the parent node of this statement, which eventually is, for example, the function, and then eventually the class to which this function belongs, you're going to be able to figure out whether this variable X is declared either in this function as a variable or as a member of the class, for example. Okay. So in this second part here, what you will do is once you encounter IDs, then you're going to check in the table if they are declared. And eventually you're gonna do another stage where you will do some binding of these IDs, and you're gonna be able to do, for example, semantic checking, such as when you're calling a function, you will bind it to a certain function declaration in the symbol table, and then you're gonna be able to check if the call to this function is properly called, if it has the right number of parameters or the right type of parameters. Talking about types, you're going to be also in another phase, be able to, another traversal possibly, to be able to do the type checking of entire expressions. For example, if you pass as a parameter to a function call, if you pass an expression, and if you want to know if the parameter that you pass is of the right type for this function, you need to know what is the type of the entire expression. Then once you know the type of the entire expression, you can check if this value, which is of certain type, is of the right type, for example, this particular parameter of this function. You'll be able to do type checking, which is going to be able to enable you to do that kind of check. Okay, so first of all, do the symbol table creation, and then for each of the different checks that you need to do, for which you have a list below, implement some semantic actions that do these checks. I strongly suggest, again, that you use the visitor pattern and that you look in the code that I've designed, the Java program I pointed out to you before. It's very handy to look at this code. It actually tells you exactly what to do. Many of the operations that you will have to do have been implemented in this code. Okay. It's going to give you some hints about how to organize things. It does not include everything, it includes some of the things that you have to do. Okay. So this is all, it's here a brief discussion as to what are essentially the semantic concepts that are involved in this language. We will discuss that in class. Okay, so I'm going to go over each of these bullets here, and I'm going to have a discussion about them in class. So this is essentially a list of all the semantic concepts that are involved in the language. And then eventually here, I'm listing all the semantic checks that you actually need to do from 1 to 15. If you remember when I show you the source file that has some semantic errors in the folder, in the zip file, there were some errors that were listed. Can go maybe back to this file. So from 1 to 15 here. So these are all the different kinds of errors that are referred to here from 1 to 15. Okay. So essentially, for each of these numbers here, then you're going to have at least one semantic action that is going to be implemented, hopefully as a visitor action. So when you come up with a certain kind of node, then a certain semantic action is going to be triggered that is going to do one of these checks. Okay. So each of them is not necessarily very complicated. Well, some of them have their own complications. Some of them are extremely simple. So it's important that you look at them and then you somehow pick and choose the easy ones. And some are much more complicated than others. So it's up to you to see what you think you can do easily, and then pick and choose and maximize your grade. Eventually, always some students have enough time to do all of this, which is magnificent. But sometimes a lot of students don't have time to finish everything. again, you don't have to finish all these checks in order to be able to do assignment number 5. Okay, there's not much correlation between the second part, just the semantic checking, and being able to do assignment number 5. You absolutely need to have the symbol tables, though, in order to do assignment number 5. So that's the minimum you should do if you want to do assignment number 5 or be able to do assignment number 5. You must have the symbol tables. Then for each of these different checks, there is possibly a different kind of semantic error that should be reported and output into the out semantic errors file. That's another file that you must output as a result of your compilation process. I've also shown you before, you must output to a file, a text file, a representation, a text representation of your symbol tables data structure. And eventually you have to provide your own test cases as well as design a driver that you will use for your demonstration. So that's about it for that. Very important for this one that you come to class and that you, when we have a discussion, especially on the visitor pattern, I can't stress that enough. Again, I repeat, I strongly suggest that you use the visitor pattern. There's a kind of a steep learning curve to it in the beginning, but once you get the hang of it, it's going to make your life so much easier. So there is the video and the slides about this for the lecture. There will be also, there is a video for the lab. It's going to be discussing about this for this week's lab. The lab instructor is going to be there to explain that also. So plenty of resources for this aspect, very important aspect of this assignment. The visitor pattern is also going to be very helpful for assignment number 5. So it's very important that you consider it. Thank you. Bye-bye.